JEE Advanced 2025, Paper 2, Physics, Question 10. Let us visualize the two processes. In process 1, a hydrogen atom in its ground state absorbs a photon of frequency Nu1. The electron is ejected with a kinetic energy of 10 electron volts, leaving behind a proton. In process 2, the ejected electron with 10 eV kinetic energy combines with a positron at rest. They form a positronium atom in its ground state, while simultaneously emitting a photon of frequency Nu2. The positronium moves with a kinetic energy of 5 eV. Here is the question. A hydrogen atom, initially at rest in its ground state, absorbs a photon of frequency Nu1 and ejects the electron with a kinetic energy of 10 electron volts. The electron then combines with a positron at rest to form a positronium atom in its ground state, simultaneously emitting a photon of frequency Nu2. The center of mass of the positronium moves with a kinetic energy of 5 electron volts. We are given that positron has the same mass as the electron, and positronium can be treated as a Bohr atom. We need to find the difference between the two photon energies, Nu1 minus Nu2, in electron volts. Let us review the key concepts needed for this problem. First, photoionization of hydrogen. The photon energy Nu1 must provide the ionization energy of 13.6 eV for ground state hydrogen, plus the kinetic energy of the ejected electron. Second, positronium as a Bohr atom. The reduced mass of the electron-positron system is half the electron mass. So the energy levels are En equals minus 13.6 over 2n squared electron volts. The ground state energy is minus 6.8 eV. Third, energy conservation applies to each process. Since we have two particles of mass me combining into a bound state also of mass approximately 2 meters e, the rest mass energies cancel out. Fourth, the binding energy convention. A bound state has less energy than the free particles. The difference goes into the emitted photon and kinetic energy. Let us solve process 1. The hydrogen atom absorbs a photon and gets ionized. By energy conservation, the photon energy Nu1 equals the ionization energy of the ground state, 13.6 eV, plus the kinetic energy of the ejected electron, which is 10 eV. We neglect the proton recoil energy since the proton is much heavier. So Nu1 equals 13.6 plus 10, giving us 23.6 electron volts. Now for process 2. First, let us find the ground state energy of positronium. The reduced mass mu equals me times me over me plus me, which gives me over 2. So the energy levels of positronium are minus 13.6 over 2n squared. For the ground state, n equals 1, giving E equals minus 6.8 eV. Now applying energy conservation. The rest mass is 2 meters E on both sides, so it cancels. The kinetic energy of the electron, 10 eV, goes into the binding energy of positronium, the kinetic energy of positronium, and the photon energy. The bound state has energy negative 6.8 eV, meaning it has 6.8 eV less than the free particles. So we write 10 equals negative 6.8 plus 5 plus Nu2. Solving, Nu2 equals 10 minus 5 plus 6.8, which is 11.8 eV. Now we find the difference. From process 1, Nu1 is 23.6 eV. From process 2, Nu2 is 11.8 eV. Therefore, Nu1 minus Nu2 equals 23.6 minus 11.8, which gives us 11.8 electron volts. The acceptable answer range is 11.7 to 11.9 eV. The correct answer is 11.8 electron volts. Nu1, the absorbed photon, has energy 23.6 eV. Nu2, the emitted photon during positronium formation, has energy 11.8 eV. Their difference is exactly 11.8 electron volts. Here are important tips for JEE Advanced modern physics problems. First, positronium is a frequently tested topic. Remember that its reduced mass is half the electron mass, so all energy levels are halved compared to hydrogen. Second, in energy conservation problems, when the same total rest mass appears on both sides, the rest mass energy cancels out. Third, binding energy carries a negative sign. Forming a bound state releases energy that goes into the emitted photon and kinetic energy. Fourth, always check whether recoil is significant. Here the proton recoil is negligible because the proton is much heavier than the electron. But the positronium recoil of 5 eV is significant and must be included. Fifth, for numerical type answers, maintain one decimal place, and verify your answer falls within the acceptable range. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.